GitHub just announced Copilot Agent Mode. Microsoft revealed autonomous coding agents at Build 2025. Devin AI promises to replace entire development teams. Today we're diving deep into AI coding, agents, what they actually are, how they differ from simple automation, and whether you should build one yourself.
Sam, the term AI agent is being thrown around everywhere, but most people don't understand what makes something an agent versus just automation. A true AI coding agent has autonomy, reasoning capabilities, and can adapt its approach based on context.
I've implemented multiple coding agents in production. The difference is dramatic. Traditional automation follows scripts, but agents like Cursor's Agent Mode or GitHub Copilot Agent actually reason about code structure and make independent decisions.
The market is exploding. Cursor raised $60 million, Devin's at $500 per month, and 99% of enterprise developers are exploring coding agents according to IBM's survey. But most implementations I see are just glorified automation scripts.
As someone who's used both traditional CI/CD automation and newer agents like Windsurf, the experience is completely different. Agents understand intent and adapt, while automation just follows predefined rules.
Let's start with fundamentals. Dr. Chen, what exactly makes something an AI agent rather than just sophisticated automation?
3 key characteristics define AI agents: autonomy, reasoning, and adaptability. Automation executes predefined workflows. Agents perceive their environment, make decisions, and take actions to achieve goals with minimal human supervision.
Think of it this way: a traditional deployment script follows exact steps. An AI agent looks at your codebase, understands the context, identifies issues, and figures out how to solve them independently. It's problem-solving versus task execution.
The technical difference is that agents use large language models as their reasoning engine. They can interpret natural language instructions, understand code semantics, and generate novel solutions rather than following predetermined paths.
Here's a concrete example. I told Cursor's agent optimize this React component for performance, and it analyzed the code, identified unnecessary re-renders, implemented React memo, and optimized hooks. A script couldn't do that.
Exactly, agents operate in what we call the plan-act-observe loop. They form plans, execute actions, observe results, and adjust their approach. Traditional automation lacks this feedback and adaptation mechanism.
Let's examine specific examples. James, walk us through real AI coding agents you've worked with and what they actually do.
I've deployed GitHub Copilot Agent Mode, which can autonomously refactor entire code bases. Recently, it analyzed our legacy Python service, identified bottlenecks, and rewrote critical functions without human intervention.
Devin AI goes further. It can build entire applications from natural language descriptions. Users report building functional SaaS prototypes in hours instead of weeks. It manages the complete development lifecycle autonomously.
Lovable and V0 by Vercel are game changers for front-end work. I describe a landing page, and they generate React components, handle responsive design, and even integrate with APIs. It's like having a senior developer assistant.
What's interesting is how these agents handle uncertainty. When Cursor encounters ambiguous requirements, it asks clarifying questions or suggests alternatives. That's reasoning, not scripted behavior.
The autonomous debugging capabilities are impressive. Our agent detected a memory leak in production, traced it through multiple services, identified the root cause and proposed fixes, all without human guidance.
That sounds powerful, but what are the practical use cases? Alex, where are coding agents actually providing value?
Code review automation is huge. Agents like Codo AI analyze pull requests, identify security vulnerabilities, suggest improvements, and even generate comprehensive test suites. They understand code context, not just syntax.
Legacy code modernization is where agents shine. They can translate COBOL to Java, upgrade frameworks, and refactor deprecated patterns while maintaining functionality. Amazon saved 4,500 developers using AI for Java upgrades.
Documentation generation is another sweet spot. Agents analyze codebases and generate comprehensive documentation, API references, and even architectural diagrams. They understand relationships between components.
Incident response automation is revolutionary. Our agents monitor system health, detect anomalies, correlate logs across services, and even implement fixes for known issue patterns. Response time dropped from hours to minutes.
Full-stack application generation is emerging. Bolt, Replit Agent, and Lovable can build complete applications from descriptions. Users describe functionality, and agents handle architecture, front-end, back-end, and deployment.
Let's get specific about the technology. Dr. Chen, what's actually happening under the hood of these coding agents?
Modern coding agents use large language models as their reasoning engine, typically GPT-4, Claude, or specialized models like Codex. The LLM processes natural language instructions and generates code or actions.
They have access to tools, APIs, file systems, databases, command line interfaces. The agent decides which tools to use and how to use them based on the task. It's like giving an LLM hands and eyes.
The architecture typically includes perception modules that understand code context, planning modules that break down tasks, and execution modules that interact with development environments. Everything coordinated by the LLM.
The context awareness is crucial. Agents index entire codebases, understand dependencies, and maintain conversation history. They're not just generating code in isolation, they understand the bigger picture.
Memory systems are key differentiators. Agents maintain working memory for current tasks and long-term memory for learned patterns. They can reference previous solutions and adapt them to new contexts.
What are the limitations? James, what have you learned about where these agents struggle?
Complex system architecture decisions are still challenging. Agents can implement features but struggle with high-level design choices that require business context and long-term strategic thinking.
Security considerations are often overlooked. Agents might generate functional code with subtle vulnerabilities. They lack the security mindset that experienced developers have developed through years of threats and incidents.
Performance optimization at scale is another limitation. Agents can write working code, but they don't always understand production constraints, load patterns, or optimization techniques that only come from real-world experience.
The context window limitation is significant. Even with extended context models, agents can't maintain awareness of massive code bases. They lose important details as conversations grow longer.
Cost is a practical limitation. Complex agent operations can consume thousands of tokens per task. At scale, API costs become substantial, especially for frequent agent interactions.
Let's talk about building your own. Sophia, walk us through a practical example of creating a simple coding agent.
I'll describe building a code review agent. First, define the purpose. Analyze pull requests, identify issues, and suggest improvements. This gives the agent clear goals and scope.
Choose your framework: LangChain for Python, AutoGen for multi-agent systems, or N8N for low-code development. Each has different strengths depending on your technical requirements and complexity needs.
For our code review agent, we need tools. GitHub API for accessing pull requests, static analysis tools for code quality checks, and CI/CD integration for automated testing. Tools give agents capabilities.
Design the workflow. Agent receives PR notification, fetches code changes, runs analysis tools, correlates findings with code context, and generates human-readable feedback. Each step requires decision-making logic.
Implementation involves prompt engineering for the LLM, error handling for tool interactions, and safety checks to prevent harmful actions. The prompt is crucial. It defines the agent's behavior and personality.
Here's sample code structure. Define tools for GitHub and analysis, create prompts for code review instructions, implement the decision loop that processes requests and generates responses, and add monitoring for performance tracking.
Let's dive deeper into the technical implementation. Dr. Chen, what does the actual code look like?
Using LangChain, you define tools as Python functions with decorators that describe their purpose. The agent calls these functions based on natural language reasoning. It's like giving an LLM a programming interface.
For GitHub integration, create a tool that fetches PR data, file changes, and diff information. The agent uses this data to understand what code changed and needs review. Context is everything for quality analysis.
Static analysis integration requires wrapping tools like EaseLint, SonarQuebec, or custom security scanners. The agent correlates tool output with code context to provide meaningful feedback instead of raw error lists.
The prompt engineering is critical. You need to define the agent's role, provide coding standards, specify output format, and include examples of good reviews. The prompt is the agent's personality and knowledge base.
Memory management involves storing conversation history, maintaining codebase context, and persisting learned patterns. Agents need to remember previous reviews to maintain consistency and improve over time.
What about more advanced agents? James, how do you build agents that can handle complex, multi-step development tasks?
Multi-agent systems are powerful for complex tasks. Create specialized agents for different concerns: architecture, security, testing, deployment. Then orchestrate them to collaborate on larger problems.
Planning modules become essential. Agents need to break down high-level requests into actionable steps, handle dependencies between tasks, and adapt plans when obstacles arise. This requires sophisticated reasoning capabilities.
Error recovery is crucial for autonomous agents. They need to detect when actions fail, understand why, and try alternative approaches. Without this, agents get stuck on simple problems.
Tool integration becomes more sophisticated with APIs for cloud services, monitoring systems, communication platforms, and development environments. Agents need broad access to be truly autonomous.
Safety mechanisms are non-negotiable. Implement approval workflows for high-risk actions, sandbox environments for testing, and rollback capabilities for when agents make mistakes. Autonomy requires safeguards.
Let's talk about practical considerations. Alex, what should teams think about before implementing coding agents?
Start small with narrow, well-defined tasks. Don't try to build a general-purpose coding assistant immediately. Focus on specific problems like code review, documentation generation, or test automation.
Consider your data requirements. Agents need access to codebases, documentation, and historical patterns. Data quality and accessibility directly impact agent effectiveness. Garbage in, garbage out applies here.
Team readiness is crucial. Developers need to understand how to work with agents, when to trust their suggestions, and how to provide feedback. Change management is as important as technology.
Infrastructure considerations include API rate limits, token costs, latency requirements, and integration complexity. Agents can be resource-intensive, especially for real-time interactions.
Measurement and evaluation frameworks are essential. Define success metrics, establish baselines, and implement monitoring to track agent performance, user satisfaction, and business impact over time.
What about security and governance? Dr. Chen, how do you ensure coding agents don't introduce risks?
Implement least privilege access controls. Agents should only access resources necessary for their tasks. Use service accounts with limited permissions and audit all agent actions for compliance and security.
Code review processes remain important. Even autonomous agents should have their outputs reviewed, especially for security-critical or high-impact changes. Human oversight prevents catastrophic mistakes.
Data governance becomes critical. Agents process sensitive code and business logic. Implement encryption, access logging, and compliance controls to protect intellectual property and meet regulatory requirements.
Version control and rollback capabilities are essential. Agents should commit changes with clear descriptions, maintain audit trails, and enable easy reversal of problematic modifications.
Testing and isolation is crucial. Use sandbox environments, mock APIs, and restricted data sets to validate agent behavior before production deployment. Unexpected agent actions can cause significant damage.
Let's discuss real-world results. James, what outcomes have you seen from implementing coding agents?
Code review time decreased by 60%, but more importantly, review quality improved. Agents catch subtle issues humans miss, while humans focus on architectural and business logic concerns.
Documentation coverage increased dramatically. Our agent automatically generates and updates documentation as code changes, ensuring consistency and reducing the burden on developers to maintain docs manually.
Development velocity improved, but the biggest impact was reducing cognitive load. Developers focus on creative problem-solving while agents handle routine tasks like boilerplate generation and dependency updates.
Bug detection rates improved significantly. Agents analyze patterns across the entire codebase and identify potential issues that isolated testing might miss. They provide broader context than traditional testing.
Incident response time dropped from hours to minutes for common issues. Agents quickly correlate symptoms with known patterns and implement fixes automatically, reserving human attention for novel problems.
What challenges did you encounter? Sophia, what went wrong and how did you address it?
Over-reliance was a major issue. Developers started trusting agent suggestions blindly, leading to subtle bugs and architectural problems. We implemented mandatory review processes for agent-generated code.
Context loss in long conversations was problematic. Agents would forget important requirements or make contradictory decisions. We implemented better memory systems and conversation summarization techniques.
Cost explosion was unexpected. Complex agents can consume thousands of tokens per interaction. We implemented usage monitoring, optimization strategies, and cost-aware operation modes.
Integration complexity was underestimated. Agents need access to multiple systems, each with different APIs, authentication methods, and data formats. Standardization became essential for maintainability.
Agent personality inconsistencies were confusing for teams. Different prompts produced different coding styles and decision patterns. We developed standardized prompt templates and style guides.
Looking forward, where do you see coding agents heading? Dr. Chen, what's the future landscape?
Multimodal agents that understand visual interfaces, diagrams, and documentation will emerge. Agents will work directly with design tools, interpret screenshots, and generate code from visual mockups.
Specialized agents for different domains will proliferate. Healthcare agents understanding HIPAA, financial agents knowing compliance requirements, and gaming agents optimized for performance and user experience.
Real-time collaboration between human developers and agents will improve. Agents will participate in stand-up meetings, code reviews, and architectural discussions as active team members, not just tools.
Learning from production feedback will become standard. Agents will monitor how their code performs in production and incorporate that feedback into future decisions, creating a continuous improvement loop.
Agent marketplaces will emerge where teams can share, customize, and deploy specialized agents. Think of it as an app store for development tools, with agents tailored for specific frameworks and industries.
What advice would you give to teams considering implementing coding agents? Alex, what are the key recommendations?
Start with pilot projects in low-risk areas. Choose well-defined problems with clear success metrics. Build internal expertise before committing to large-scale agent deployments across critical systems.
Invest heavily in monitoring and observability. You need to understand what agents are doing, why they make decisions, and how to debug problems. Transparency is crucial for production systems.
Focus on human-agent collaboration, not replacement. The best results come when agents amplify human capabilities rather than trying to replace human judgment entirely. Partnership, not automation.
Design for explainability from the beginning. Teams need to understand agent reasoning, especially when things go wrong. Black box agents are problematic for mission-critical development workflows.
Consider the total cost of ownership, not just API costs, but development time, maintenance overhead, training requirements, and infrastructure needs. Agents are powerful but not free to operate.
Any final thoughts on the distinction between coding agents and traditional automation?
The fundamental difference is reasoning versus execution. Automation follows scripts, agents solve problems. Both have their place, but agents represent a qualitative leap in what's possible with software development tooling.
Agents adapt to new situations, while automation breaks when assumptions change. In complex, evolving code bases, this adaptability is invaluable for maintaining development velocity without sacrificing quality.
For developers, agents feel like working with a knowledgeable colleague rather than using a tool. They understand context, ask clarifying questions, and provide explanations. It's a fundamentally different experience.
The market is moving rapidly toward agent-first development workflows. Teams that understand and implement agents effectively will have significant competitive advantages in development speed and code quality.
Remember that agents are still evolving technology. What we see today is just the beginning. The agents of 2026 will be dramatically more capable than current implementations. plan for growth, and continued learning.
Dr. Chen, James, Alex, Sophia, thank you for this comprehensive exploration of AI coding agents. You've shown us both the transformative potential and the practical realities of implementing these systems.
Thanks, Sam. The key takeaway is that coding agents represent a genuine paradigm shift. They're not just better automation, they're a new category of development tool that requires new thinking about how we build software.
Appreciate the discussion. For teams considering agents, start small, measure everything, and focus on human-agent collaboration. The technology is powerful but requires thoughtful implementation.
Great conversation. The agent market is exploding, but success requires understanding the difference between hype and practical value. Focus on solving real problems, not just implementing cool technology.
Thanks for having me. For developers, agents are becoming as essential as IDEs and version control. Learning to work with them effectively is crucial for staying competitive in the evolving development landscape.
This episode was brought to you by Unstruct AI, creating the most trusted AI news analysis platform, with a focus on the human cost. After all, progress without humanity isn't progress at all. Next week, we'll explore the economics of AI agent deployments and examine whether the productivity gains justify the costs, complexity, and risks of autonomous development systems. Until then, remember, agents should amplify human intelligence, not replace human judgment. The future of development is collaboration, not automation. This has been Unstruct AI, where we examine technology's human impact.